Let's take a look at this problem. We've got f of x is equal to e to the x squared minus 3 power over e to the x plus 2. Well, we want to find derivatives, so this would be the quotient rule. So the top part is p, the bottom part is q. We need p prime and q prime. P prime, the derivative of e to the x squared minus 3 is e to the x squared minus 3 times the derivative of x squared minus 3. Well, the derivative of x squared minus 3 is 2x, so that's 2x e to the x squared minus 3. Now for q prime, the derivative of e to the x plus 2 is e to the x. 2 drops away. And since this is just a single x here, I don't have to multiply times the derivative of the exponent. If I do, it doesn't hurt anything. Derivative of x is 1. Quotient rule. We got p prime q minus p q prime over q squared. So for our derivative, p prime was 2x e to the x squared minus 3 times q, which is e to the x plus 2, minus p, which is e to the x squared minus 3, times q prime, which is e to the x, all over q squared, which is e to the x plus 2 squared. Now let me double check all that. So p prime times q minus p times q prime over that. Okay. First thing I notice up on top is I got this group and I got this group. Why do I consider those groups? Is because they everything's multiplication. 2 times x times e to the power times parentheses. Over here, e to the power times e to the power. Now on those, I notice they both have an e to the x squared minus 3. So I can factor that out. And here that leaves me 2x times e to the x plus 2 minus e to the x, all over e to the x plus 2 squared. Well, let me get rid of the parentheses inside there, see if I can combine anything together. So we got e to the x squared minus 3 times 2x times e to the x is 2x e to the x. 2x times 2 is 4x minus e to the x, all over e to the x plus 2 squared. Now there's really nothing I can combine together inside the parentheses here. I mean, this has an e to the x and this does, but this one doesn't. If they all three had it, I could factor in an e to the x out. And again, nothing's alike, so I can't combine anything together. So this would be our answer.